All right, surface demo. So if you go to Box Project 4, 1104 surface demo, you can download this SolidWorks part, which will start the master sketches for you. And also this PDF is on here called Surfacing 2, the printouts I gave you all. Surfacing, so I'm going to go ahead and open that file that starts us off. Surfacing is very there's similarities to solid body modeling, and there's differences. The main difference, if you want to think about a cube in SolidWorks, it's a solid body that's essentially made up of 6 surfaces. So, for example, if I just quickly build one for the purpose of talking about it, a solid body has mass. There's object inside of it. But a surface is a single face here. So the main difference, if you think about it, when if a solid body is made by a shape, a surface is made by a line. And so I don't know how the SolidWorks program or algorithm works, but surfacing tends to be more robust. It tends to be able to do more complex things. And my like simple understanding of it or explanation of it is that because you're dealing with a single line as opposed to a complete shape, the program can handle that calculation better. So surfacing, in short, is useful for doing anything kind of complex or organic. This demo that I'm about to go through is the knob that we worked on for project 2, but we're going to build it with surfacing purely. If you'll recall with the knob in project 2, some of the like lofting, there was issues with tangency and getting things to blend and look nice and smooth. Surfacing tends to get rid of that and makes your life easier in that aspect. So moving into the demo. What's given here is front master, top master, and side master based on the front and the top. So it asks you to start by creating a new front plane sketch. And we're going to go ahead and pull these 3 lines. So I can go ahead and hit C for convert entities, or hit this up here. Reminder that convert entities essentially copies it, but it's still linked to the original copy. So if the original copy changes, this one changes too. You know what? I already made a mistake. Actually, you're also supposed to copy this line here, but the difference is you want to take this line and make it for construction. If I hit Alt-V to hide all the other sketches, this is the first sketch you all create. You want to go ahead to go to Surfaces and click on Revolve Surface. Because this is for construction, it automatically knows that that's the line to revolve around. If you forget to make this for construction, they will give you an error, because if you're trying to revolve about a solid line, you're kind of creating a zero surface. Let me just quickly show you what I mean. So if this is not for construction, and I go ahead and go here to revolve surface, and I select this line to revolve it around, you'll see it doesn't complete it. And again, that's because it's reading this line. It's trying to create a surface from this line, and because it's about the center, the computer can't solve that problem. It's like dividing by 0. It's asking to revolve about itself. So don't forget, very important, to take this and make it for construction, and then click on Revolve Surface here. We want to build this knob in quarters. It is always more efficient whenever you can build in quarters or halves to do so. So it is important though, so you type 90 degrees in there, Alt-V to turn this back on. It is important to go in the right direction because our other sketch is on this other side. So I'm going to click on this to invert the direction that it's going. And I'm going to go ahead and click check. So just like I made my analogy before, whereas a solid body is a piece of clay, a surface is like a piece of paper, or a shape versus a line. These are the 3 lines that make our surface. It's open on the inside. The next thing the demo asks you to do is create a new top sketch and pull this sketch from the top master. This is another surface thing. It's just like in our solid body features with extrude, extrude cut, and all those things, there are similar features in surfaces. Like we just used the revolve surface, similar to a revolved body. Here, instead of extrude cut, it's called trim surface. So you can still be in the sketch and click on trim surface. Because we're still in the sketch, it automatically loads that to be the trim tool. And here you can toggle between whether you want to keep the selections or remove the selections. Often that's interchangeable. My advice is to do whatever is less clicking. So if you're getting rid of more surfaces, then click on keep selections. In this instance, we want to remove just the inside upper portion. So I can click on that. If you click on the bottom one, you'll remove that as well, but we just want to remove the top. And go ahead and click check. For those of you that are astute and paying attention and are all about efficiency, I could have skipped this trim step by changing my revolve here and aligning this top edge with, if I drag on this corner, can I do that? It's not letting me. If I trim this line to be this long, I could have skipped a step. What's up? Yeah, I don't want to be in the master for this. Okay, here, I'll show you what I'm trying to say. If I just like draw a line here, just for construction, and say T for trim to trim this out, provided that's still for construction. If I exit this out, I mean, it's going to give me an error now because of the trim. But basically, I could have gotten to this portion a lot quicker without having to trim it. So just be aware, there's always like faster goals to your end result. Here, the trim is useful to learn the trim, and because then you don't have to go through this. It's like choose what different extra step you want to go through, basically. But yeah, just like any other program, there's different paths to the same end result. Okay, the next thing that the demo has you do is to create a new front plane sketch and to copy this portion. So I convert entities there. Let's see, then the next thing it has you do is create a new right plane sketch and copy this one here and exit out. So now I have these two sketches which are ready to be lofted together. If I look at what this has us do, it goes right into a loft, which is totally okay. You could, you'll notice that there's this in the master. You could, if you wanted, this is not in the demo, but just for your reference, if you're trying to control that loft a little bit more, you could, you know what, sorry, let me back up. I'll show you what the demo talks about, and then I'll show you a slightly more controlled way to loft it. So the demo then has you take these two sketches and loft them together. So again, just like everything else in the feature tree, there's also a lofted surface. You could, what does it have you say? Okay, so it has you select lofted surface. So here it's asking you what profiles you want to loft. It could be tempting to just click here in the view plane, but keep in mind that's a way that you might accidentally select the master sketch. So you could select the sketches from here, or you could hide the master sketches and then select from the tree. It doesn't matter what you do. But the quickest way would probably be to select both of these from the expanded tree this way. And you can see that it just kind of jumps between one to the other. Again, this is where surfacing is nice. It has this kind of like, even though they're straight lines, it has a nice kind of gentle blend through there. But what it asks you to do is make a couple settings changes. So firstly, we want to go normal to profile. This is how we get the tangency. So when we mirror this, it will be nice and smooth from one to another. Also, for what it's worth, down here in guide curves, this is where you want to select this edge, and it will blend this through here. It asks you to then go ahead and click check. Now, what I was starting to say was if you wanted to control this loft a bit more, you could control this top portion. So this is beyond the demo. But for example, you could roll this tree back, insert a new plane, insert reference geometry plane. I was happy to see in project 3 when I was creating it that some of you created planes as I suggested, which again is my advice is always to select a line and a dot. It's the quickest way to make a plane. We could, on this new plane, copy this sketch. So again, convert entities, and that's all we need. And now if we edit this loft, you can see if we want to control what's going on the top, it's simply just a matter of going down here and selecting this as a new guide curve. And it will help control through that. You don't have to. Again, it's just sketches are all, or lofts are always best if you're having trouble with lofts, more control should help you. The only time when control is bad is if you're asking it to do too much. So I guess there's no like rule of thumb. It depends on what your end goal is. Okay. So now simply to complete the demo, it has you knit the surfaces together. So this is, again, to me, this looks like a life jacket. So it has you select that. This is like a body combine is a way to think about it. So now this is one surface. If I roll back before the knit, you'll see that we have two surfaces here. Roll back after the knit, we now have one. It then has you mirror this. So this is the one confusing thing. Mirror is still under the main features tab. So you can go to mirror. Again, here, other confusing thing, you're mirroring, it says bodies, but technically it's a surface. So you're you select the surface within the bodies to mirror. Kind of a confusing language thing in SOLIDWORKS. And you'll notice down here there's different options. So I tend to uncheck propagate visual properties because that can cause a bug sometimes in that if you're applying material to things, it gets confused as to like what's the most important material to remember. That's kind of an aside. The takeaway is if you remember, uncheck that. If you don't remember, it's not a big deal. In this instance, you want to check knit surfaces because we want to combine this. So go ahead and click that check mark. And again, we still have one surface body. You can see it's smooth through here. It then has you do this again on the right plane or whatever plane you didn't do before. Once again, select the bodies, merge solids. I tend to uncheck this. And then we have, oops, did it not? My bad, yep, knit surfaces. So that's knit. Now last but not least, this is another surface thing. If you have an open face on here, in order to make it a solid body, you need to have all of the like open surfaces sealed. It is good eventually to go back to a solid body because then you can like remove, if I were to try and like scallop this, it would be incredibly complicated to do it with surfacing. It's doable, but it would be easier to do it with like a sweep cut like we've learned. So surfacing is good for like getting your main form or getting a complex area figured out, but sometimes solid bodies are better for like scooping away material or cutting a hole through it, what have you. So to complete the demo, you want to go to filled surface, and this just basically asks you to select an open face. So what's the patch boundary? Like what is the boundary that you want to create a patch in? We simply select these four edges. You'll notice it gives us a yellow highlight to let us know it's completing that. We can go ahead and click check. And now we want to, when you want to take surfaces into a solid body, the best way to do that is with surface knit. Here again, it asks you for the selections. You want to check create solid and go ahead and check that box. And now you'll see we have a solid body. If I, to my point made before, if I want to now like, I don't know, scoop away part of this with a cut to make a grip detail. No, this grip detail doesn't make any sense, but just to make a point. Now there's like solid body underneath there. That's resulting. For what it's worth, the other way to make a solid body from a surface is with thicken. Thicken is not as robust as knitting to create a solid. So for example, if I hide this, I could like try and thicken this surface. Thicken sometimes just runs into issues, especially if you have like fillets and stuff. You can run into issues with thicken, but it's good to know that it exists. For what it's worth, you can fillet a surface body. So I can go back here and I can throw fillets on this edges. And all it does is it just on the inside, it's paper thin. So the fillet now also exists on the inside as on the outside. You cannot, however, like fillet this edge because like there's nothing to fillet to. It has to be a corner. And you'll see if I roll down now and, well, not the thicken, but yeah, the reason the thicken failed is the thick command doesn't like fillets because what it does is it offsets that face. And if it offsets that face and gets like to a 0 or a non-resulting effect, it doesn't like that. I can draw that up here in a minute to explain what that means. So the question was, if you create a plane based on a line and move that line, does the plane move? And yes, it does. And that's why it's good to create it this way off the master sketch. If your boss comes back or you decide you want to change the proportion or someone tells you that it should only be an inch tall, and I move this, sorry, let me suppress the thicken command and unsuppress these. Where are we at? It moves the plane down. So it's still there, and it's still controlling that. Good question. Yes, you do always, in general, you always want to turn a surface body back to a solid. When it comes to like 3D printing, when it comes to rendering, I believe solid bodies are preferred. And again, it's just, yeah, sometimes you want to like check mass. I mean, it depends. If you're doing like rough design CAD, sometimes it's okay to leave it as a surface if all you need is the outer render. But it's best practice to return to a solid body. So it's like expected.
So you use surfacing to create a complicated shape and then you turn it back into a, is there any time you create a surface body that can't be turned into a solid body?
Sometimes, yeah, sometimes like you're trying to knit something complex, you might have a hole somewhere you can't find. Okay. Sometimes surface, like there's something that's weird or not resulting that it can't knit. But for sure, if you're like working on something final or going to production or making a drawing, yeah, you want it to be a solid. The only time surfacing is okay is like if it's just like something loose and you're doing it for yourself. Okay. But solid bodies are expected.
Okay. So don't turn in a project with just the surface.
For me in my class, I won't like that.
That's what I was more like. If I left in a surface by accident, it would be
deducted. Let's say for project 4. I know that there are some surfaces in project 3. That's okay. Again, it's just for render, but for the most part, best practice to make it a solid body. So, okay, the question is about revolving and like what can we do when it comes to revolving a surface. It's helpful to sketch the line that you want to revolve around. I would always recommend that. It's not necessary, however. Let's see if I can do this here. I believe I can make a sketch that is, let's see if it can be disconnected. I think it can. And let's say that I have something in here already to reference. I'll just extrude a cylinder. Now I believe that I can, under surfaces, go to revolve surface. Come on now. Select a plane. Okay, so it's asking me to select a sketch. So I want to revolve this sketch. And now it says, hey, what's the axis of revolution? I don't think I can select an edge, but I'll try it. Nope, I can't. It's not even letting me click on it. However, what I could do is, again, here in the Hide Show tab, I can say temporary axes. And I can just hide sketches right for the minute now, just so that it's not so confusing. And there's an axis in here. Let's see if I can select that. I believe I can. Yes, I can. So you can see they're not even connected, and there's no sketch to revolve around. So you can revolve around an axis. Now that said, I would always recommend having the axis of revolution inside the sketch. It's just better practice, as opposed to relying on something external like this cylinder.
So X doesn't have to connect.
It does not have to connect. And like you could even, yeah, even with solids it doesn't have to. You could also like, your axes could be whatever you want it to be. Like it could be something crazy like, well, it's not that, come on. Oh, it's because, okay, sorry, give me a minute, technical difficulties. Your axes could be like somewhere off at a weird angle like this. And like we could revolve it. Oops, that's not a revolve. We could revolve it around, oh, Jesus.
Too many things.
I broke it. We could revolve it around, you know, a weird angle.
Oh, what's happening if you make this solid?
Oh, if you made this like, well, if I tried to do this as a solid revolve, it would try to,
No, like convert this surface to solid.
you can't. It's not possible. It's not closed, unless you do the thicken command.
I thought it didn't have to be closed for you to.
So in order to make this a solid, there's two ways to do it. You could do thicken and select this and offset it, and that now it's solid. You'll see we have a solid body here. Or yeah, you can patch it. So you could say like, you could once again go to filled surface and select this edge and click a check mark, and back to filled surface and select this edge and do it. Or you could also like do a surface loft. You could like loft this edge to this inner edge up in here. And that completes it. And then you would need to complete this here. So once again, you need to go to a filled surface and select this. But then what you would need to do is then, of course, go to knit, select this, 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 and this, and say create solid. And now that can make it a solid. So there's different ways to go about that. For what it's worth, when you do the filled surface, if you first do a sketch that is, what's key is that this point and this line are piercing, so it's black. This one auto pierced there. If I now roll down to this filled surface, if I go to constraint curves down here in pink, and I have to go back here and turn my sketches back on so I can actually see it. So I'm now here selecting a constraint curve. I can select this, and now the patch will make it a reverse dome.
So you don't have to sweep up the
You don't have to sweep, right, you don't have to do a sweep cut. It's just a way to like get a manual dome in there. So surfacing is incredibly powerful. You can get like more nuanced stuff. You can also like use it to like, sometimes you might have a weird resulting body in your object. You can use surfacing to delete faces away and like patch it with surfacing. Let me see if I can remember. Yeah, let's pause. So for example, you can use surfacing to clean up, like let's say you have a resulting body that you didn't necessarily want. So like this is poking through, maybe we wanted the scalp to be nice and smooth. You could, for example, go to delete face, select this portion out, check that box, now we have a hole in here. And now if you recall what we just learned with surface fill, so on this front plane we could create a sketch. What I would do is I would actually select this face. Actually, okay, here's something brand new for everybody. This is useful to know. In convert entities, there is a cousin of it called intersection curve. So right now, we are on the front plane. If I select this face and go here and select intersection curve, it takes a line that's on that face and on that plane. It's super handy. So what I want to do now is I can take this line and I can drag it forward, and hopefully it coincides with this here. Let's see if we can hit pierce. No, it doesn't like that. So what I'm going to do is I'm going to drag it back to where we got it from. Or here I'm going to pierce it to where it was from. And now I can, here's an area where I would either use, I don't know, I'd be tempted to use a spline. And what I would do with this spline is I would start it there. I would have it be tangent to this here. Or sorry, coincident to this here. Pierce, rather. I would draw a line going off to the side, maybe, horizontal. And now I'd make the spline tangent to both of these things. So be tangent and be tangent. I could have done an arc. An arc might not have been tangent horizontally on this outer side. Okay, so that's why I use this line. But no, an arc would work too, especially if you don't care about this being tangent on the side. This might be a weird result. I don't know. We'll see what happens. But now I can go to filled surface. I can select all of these edges. What's going to be weird is that there's corners here, so that might lead to some funny geometry. You could change the settings here. Like I could change all of these settings to tangent. But again, it might, like weird things might happen. Or I could go again to constraint curves and use this. Also not happy.
It looks like loops.
So okay, neither of those things work, but we could just go ahead and just patch it like as is. It's also kind of a weird result. Anyway.
Could you just cut, like you did how you deleted that area, could you just make like a square and delete it and then
You could.
do a,
That's
so
all.
instead of having this weird
Yep. That's also totally done sometimes, where you could totally like, from a top view, to your point, you could like make a sketch across here. You could split line like along here and here, or yeah, just here. And then now when you go to the delete face, you have more you can delete. So you could also just go ahead and delete this surface as well. And in fact, now in this case, you could complete this with a surface loft. You could loft from this edge. Again, reminder that you can right click to select multiple edges, selection manager. So you don't have to loft from a sketch to a sketch, you can loft from an edge to an edge. And now here I can drag this way. And for constraint curves, I would pull this edge and this edge. Again, to your point, we could now take this first edge and say, be tangent. And now I can check this. And now this is a smoother result.
that like a month ago, but
Wait, but you don't need the line then, right? You just select edges.
Say that again?
You don't need this line that you create the convert entities in the middle.
No.
Close the,
Well, in this example that I just gave,
and yeah, just the,
because of the loft, because it's done with a loft, and because we selected a tangency from the start, it smoothed it out for us. And we kind of have the guide curves with this edge here on the side in the purples. Yes, because there's a hard corner here. If this was smoothed out, you would get a smooth surface. So the way that I split this and deleted the face, if I wanted that to be smooth, I would sketch an arc from this point to this point, split the face through here, and then delete that portion. It's a command. It's called delete face. It's right there. If I edit this command so you want to see what it looks like, all it asks you to do is literally select faces that you want to delete. Delete face will take a solid body. This is currently a solid body, and it will convert it into a surface. So once I delete that,
now it's not body anymore.
it's not a body anymore. Now, for what it's worth, I don't like these commands, but there is delete and patch and delete and fill. Like, we can see what happens and roll the dice. It does weird stuff like that. It tries to auto complete it for you. And if you check that, then it keeps it as a solid.